All right, so now we're starting a new chapter. We actually skipped chapter 2, so we're not doing chapter 2, so we're going right to chapter 3. All right, that's why it's 3:1 right here, because that's what we're doing. Parallel lines and transversals. Let's talk about what a transversal is first before we talk about parallel lines, okay? So if I have two lines, now you probably already know what parallel lines are. I think we may have even talked about it earlier on. Put that away, please. Put it away. Just put it away. That's not away. There you go. All right, so if I have two lines, these are definitely don't look parallel, do they?
No.
All right, you know what parallel means, right? Yeah, we'll talk about that in a minute. I think we've already talked about what parallel lines were earlier in the first chapter, but they're definitely they're in the same plane and they never intersect each other. These look like they don't intersect, but if they're lines, what do? They keep on what? They keep going, and eventually these two would intersect. Okay, just by looking at it, you can kind of tell. But what I'm concerned about is this. What if you had a line that crosses those two lines right there, that blue one? Okay, what do you think we call that line? A transversal. Very good, okay, because that's what we're talking about here. So it's a transversal. Let me try to write first. What grade are you guys in? You sophomores? Yeah. You need to teach somebody how to spell sophomore. Yeah, twice. I saw it. 2 misspellings of the word sophomore on the sophomore wall. It's sophomore. O-O-M. Okay, I saw it twice. But on that little marquee thing in front of Mrs. Pargo's room, you know, it says starring the sophomores. One side is correct. The other side, it says starring, but there's one R. S-T-A-R-I-N-G. That's staring. And then it says sophomores without the O in the middle of it. But on the other side, it was correct. So I don't know. Anyway, that's the problem with spell check, because nobody knows how to spell and they don't know how to find. No way. Oh, wow. All right, well, at least just leaving the O, it's not as bad as what you told me. All right, here we go. So this blue line right here is called a transversal. Okay, it's called a transversal because it crosses. Shh. Timmy, what's going on? Why are you sitting like that? How should you be sitting? I don't understand why I would even have to tell you that. Let's try this again. So the transversal is the blue one. It's the one that crosses the two lines. Okay, now we haven't even talked, well, we have talked a little bit, but we haven't mentioned that these are parallel or anything. Okay, this can still be a transversal even if we have two lines that are not parallel to each other. You could have multiple lines. You don't have to have just two. You could have multiple lines. So if I had a line here, a line right there, and a line right there, and then if I had a line like this, that blue one is still a transversal. Why is it a transversal? Because it does what to the other lines? It intersects them, okay? It intersects the other lines. So if you have one line that intersects multiple other lines, we call that the transversal, okay? Let me talk about something that I don't think they talk about in this chapter, but maybe the chapter that we skipped, chapter 2, maybe they talk about it there, but I'll talk about it right now. Again, I'm not really sure where they discuss this in the book. Maybe if somebody sees it, they can. So what if you had two lines right here? All right, so you got two lines, they intersect each other. Now, they form some angles. Do you see the angles in there that they form? All right, they form this angle right here. Okay. Yep, this is an obtuse angle, and the one across from it would be obtuse. What about this one? This would be what? Acute. What about the one across from it? That would be acute as well. So let's number these angles. Let's call this 1, 2, 3, and 4. Now, we have a thing. I don't know if it's a postulate or a theorem. It's probably a theorem because I think you can prove it. But there's a theorem that says this, that the angles that are across from each other, do you see? Which ones are across from each other? Are you two going to pay attention, or are you just going to, am I going to have you sit in the office the rest of the period? Because while I'm talking, you guys are looking at each other and having a conversation. It's not how it's supposed to be. So I need you to pay attention. I've called your name a bunch of times already. Enough. I'm tired of it. I had a couple bad classes earlier in the day, and I was kind of looking forward to this. I'm like, finally, I got lunch, and then I got that good class, and then I got yearbook, afternoon's piece of cake. But now it's turning into my morning. So let's be students. Just because you don't have paper in front of you, just because you couldn't go to your locker, does not mean you can't just sit there and pay attention to me. All right, let's try it again. So the angles that are across from each other, which ones? Some of you guys named it off. I was yelling. I wasn't listening. Okay, 1 and 2 and 3 and 4. Do you see that? So 1 and 2 are across from each other, and 3 and 4 are across from each other. We actually have a special name for that. We call them vertical angles. Vertical angles. Now, there's something that we know about the vertical angles. What do you think? What would be a wild guess? Just take a look at 1 and 2, and then take a look at 3 and 4. Just by mere guessing, what do you think might be true? There's a relationship between them.
Parallel.
They're parallel? Well, they're angles, first of all, so we don't have parallel angles. Yeah, you said it. They're equal to each other, okay? And they absolutely are. So angle 1 and angle 2 are equal, and so are 3 and 4. All right? They're not parallel angles. I just got done saying, listen, I'm answering your question. Just listen. You can't have parallel angles. That's what I said earlier, okay? That you can't have parallel angles. You have parallel lines. You don't have parallel angles. It doesn't make any sense. There's nothing that means parallel angles. Parallel lines, it's true, okay? So angles 1 and 2 are actually equal to each other. We have a theorem that says that they're equal, all right? I'm not going to really say much more than that. We're just going to keep on going after this, though. But look at 3 and 4. 3 and 4 are also equal to each other. Does that mean 1 and 3 are equal to each other? No. Okay. Now, what if this made a right angle? What if these two lines made a right angle to each other? Yeah, then all 4 would be equal to each other, wouldn't they? Okay. But that's only one situation, only one circumstance. So this situation right here, only the angles that are across from each other, but we don't call them across angles. We call them what? Vertical angles. So vertical angles are equal or congruent. Your book probably says congruent, but that's something that it's important to know. Okay, it's really important to know for what we're going to do here in a minute. Everybody with me so far? Yeah, it's been pretty easy so far. Let's do something with and you may look at this, you're like, well, these definitely aren't parallel, and there's no transversal, right? Because it's just 2 lines. To be a transversal, you got to have 2 or more lines, and then another line crosses those 2 or more lines. So we don't have any of those. How does that have to do with what we're going to talk about? Well, we'll see here in a minute, but I needed to make sure that I hit that. All right, so let's now talk about this. Let's draw just 2 random lines. They don't have to be parallel, all right? And I'll make them so they definitely don't look parallel to each other. All right, and let's click on that. Let's change that to a different color. Now, I'll tell you what, I don't need this. So, yeah, there we go. That's a little bit better. And let's move this over just a little bit. There we go. That's a little bit better. So what I'm going to do now is I'm going to mark some angles, just like I did with those vertical angles. I'm going to name a lot of these angles right here. Yeah, Matthew.
What if there was more than one line and there was like 2 different?
This is our situation. So we're not going to worry about what if, okay? Let's just worry about this one situation right here, because then I'm going to take this situation and we're going to talk about another situation, all right? So let's just worry about what's going on here. So if I said this was 1, angle 2, 3, 4, call this one 5, 6, 7, and 8. Everybody understand what that means, right? Angle 1 is this angle right here, and so on. Okay. So we have special names. So if you have paper to write on, you have that lesson plan thing I gave you. Okay, just flip it over and write it on the back of that. At least you have something written down. So we are going to give special names. We have 4 4 different special names that we're going to learn, okay? So this is more vocabulary. Let's scooch this off to the side just a little bit more so I have some room to write over here. All right, we have special names. So the first name is corresponding angles. And we're going to talk about what they are, which ones, and we're going to list all the corresponding angles. Now this is super important. So we're going to list all the corresponding angles. What it means to be corresponding is, if you look at this group of angles up here, do you see this group of 4 angles? Oops, let me try this again. See this group of 4 angles right here? And you got another clump of 4 angles down here. Do you see both of those? So look at it like this. Look at it as those 4 angles at the top, and you got the 4 angles on the bottom. So what I want to do is I want to see which ones correspond to each other, which ones match up with each other. So look at this group of 4 right here. Let's just take angle 1. Angle 1 is like the top left of those group of 4 angles. Everybody see that? So if you come down here, which one is in the top left of this group of 4 angles? Angle 3. So they would be what? Corresponding angles. So let's write that down. So angle 1. Now we're not talking about whether they're equal to each other or not equal to each other or anything like that. All we're just trying to do is just label which ones are corresponding angles, okay? We're going to talk in a few minutes about which ones are equal, which ones are not equal, and all that kind of stuff, all right? So angle 1, and I'm going to put an and, angle, what do I say? 3. All right, let's name the rest of them. Let's go angle 2. So angle 2 would be corresponding to what? Angle 4, good. And I'm just going to write up here to save myself some room. Let's go angle 5. So angle 5 and angle 7, they would be corresponding angles. And last one, what? Angle 6 and angle 8, right? They would be corresponding angles because they match up with each other. They're basically kind of in the same spot. Make sense? All right, this is top left, that's the top left. Angle 6 is the bottom right. Which one's the bottom right over here? It's angle 8. So they're the ones that match up to each other. We good with that? Corresponding angles? Yeah, we're going to hear that quite a bit. So make sure you understand what that means. Now, we have another group of angles, another relationship between the angles. And this would be, I'm going to write it down, alternate.
But never 1 and 8 would be the same.
No, 1 and 8 is completely different, okay? So they're not corresponding. 1's in the top left corner, 8's way down here on the bottom right corner, all right? So they are not the same at all. So here's another grouping, alternate interior angles. Okay, the word alternate basically means, yeah.
Oh, sorry. I was just going to say for alternate interior.
Go ahead. You tell me. Which ones do you think are alternate interior angles?
Well, there was inside.
Okay, so the interior part, okay. So let's just look at the angles that are interior. Interior means between the 2 lines, okay? Not the transversal. Remember, the pink one is the transversal. Okay, which ones are between the 2 lines? So which one are interior angles right now? What do you think? 5's an interior angle? Here's your 2 lines. It's all the stuff inside of this. 2, 6, 3. No, come on. Are you just saying that, or are you just
1, 5, 2,
the interior? Listen to me. Shh, shh, shh. Just think, okay? Don't be too quick to throw things out. Here's your 2 lines right here. See my arms? Those are your 2 lines, okay? All the stuff that's interior is between those 2 lines. All right, so all this stuff, watch, all this is the interior of those 2 lines. Is 4 an interior? Is 8? Is 1? Is 5? No, they would be what? Exterior. So which ones are the interior ones?
2, 6, 3,
2, 6, 3, and 7, okay? So that's the interior part. We got that part. Now, what does the alternate mean? Alternate means the complete opposite, okay? The complete opposite. So look at 2. Which one out of these 4, 2, 6, 3, and 7, which one would be the complete opposite of angle 2?
Just a reminder,
Angle 7.
okay.
Okay.
Are now dismissed.
So
and
angle
resume
2
boys soccer. Thank you.
and angle 7, they would be alternate interior angles. See, one's on one side of the transversal, the other one's on the other side of the transversal. One's up here at the top left, the other one is here down the bottom right. Okay? See, they're alternate, they're completely opposite. That's kind of what it means. Make sense?
Mm-hmm.
All right. So 2 and 7, there's one more pair of alternate interior angles. 6 and 3, that's right. Or 3 and 6, it doesn't really matter. I'll just say 3 and 6. Now, I haven't said anything of whether they're equal to each other or not equal to each other or anything, have I? All right, we're going to talk about that in a few minutes, okay? Guys with your heads on the desk, get them up off the desk. Let's do another one. Then now this should be pretty easy, this next one, okay? If you understand alternate interior angles, what do you think the next one's going to be? Alternate exterior angles, okay? I'm going to shorten it a little bit. Is that all right? For alternate, I'll just put ALT. Then exterior, I'll just put EXT. And then I'll just put the angle symbol. Yeah, so which one, we already mentioned earlier, which one are the exterior angles? 1, 5, 4, and 8, right? So which ones are alternate then? Angle 1 would be an alternate exterior with what? With 8. With 8. Look, 1 and 8. Okay, they're exterior angles and they're complete opposites. This one is up here at the top left. This one here is at the bottom right of all the exterior angles. So 1 and 8 would be alternate exterior angles. Everybody see that?
Yeah.
If you don't, let me know. Give me another pair. There's only one more. 5 and 4. I'll just put 4 and 5. Is that all right? All right, so they are alternate exterior angles. So on a quiz, on a test, I could give you a picture like this and put numbers in. The numbers may not be in the same exact order, so don't just like memorize, 1 and 3 are always corresponding angles. No, I could mix it up. I could have said that was angle 1, this is angle 2, this is angle 3, or something like that, okay? So, but just know which ones are corresponding, which ones are alternate interior, which ones are alternate exterior. There's one more. And these are called, if I can fit it down here, consecutive interior angles. Now, there's no consecutive exterior angles, okay? We only have consecutive interior angles. Raise this up just a little bit so I can still see the picture, and I got some more room to write. Consecutive interior angles. Now, first of all, we're talking about the interior angles. So what are my choices? I have 4 choices for my interior angles. We already said this earlier. Guys, stop it. 2, 6, 3, and 7 are my interior angles. All right? Now, what in the world does it mean to be consecutive interior angles? Well, it means basically the ones that are, I hate to even say this, consecutive means one right after the other. So I'll just show you which ones are, okay? I don't like the fact that they use this word consecutive interior angles. I used to teach out of a book, and the way that they describe these angles, they call them same side interior angles. Same side of what? Same side of the transversal. So to me, that name makes more sense than consecutive interior angles. But this book uses consecutive interior angles, and that's fine. But think of it as same side interior angles. Which one would be on the same side and interior? 2 and 3 and 6 and 7. So those are my consecutive interior angles, all right? So angles 2 and 3 and angles 6 and 7. Yeah, you can get mixed up, all right? That's why I'm trying to explain what the words mean so that when you look at it, you're not just memorizing the names of them, okay? You're looking at it and say alternate interior angles. What does it mean to be interior? It's the ones in between. What's the alternate mean? Complete opposites. Okay, yes. Fill out a pass and I'll let you go. All right, we good with this? That's really important, okay, because, I mean, not just because it's going to be on the quiz and test, but later on we do a lot of stuff with consecutive interior angles, alternate interior angles, and blah, 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 okay? Not every section or chapter throughout the rest of the book, but several times you'll see this throughout the rest of the year. These things will pop up, all right? So, you know, I've taught this many, many years. You haven't seen this before. I know it's ahead of you. I'm just trying to tell you that this is definitely something that's going to be ahead of you, all right? Let's move on. So what was the title of this lesson? It wasn't just transversals. What was it? Parallel lines and transversals, right? So let's talk about parallel lines. Let me sign this first.
Thank you.
All right, so let's draw some parallel lines. And all the stuff that we just did, we're going to come back to it in just a few minutes, okay? It won't be long at all. All right, so let's draw.
Are there ever any different type of parallel
Like what?
Like what? Like what?
I don't know. I mean, parallel lines are parallel lines. I don't know how different kind of parallel lines. I mean, they could be slanted. Like this thing right here, you could. Oops, let's try this again. If I can grab that, there we go. Look, they're still parallel to each other. Do you see that? I'm just slanting them up a little bit. All right, so maybe that's what you're thinking of. Can there be different types of parallel lines? It doesn't always have to go horizontal, right? I could have them going up like this. All right, guys. You could have two lines going up like this. They're still parallel to each other. Agreed? The thing is, it's really important what I'm going to tell you right now. You're going to see this quite a bit. If I just showed you that picture, could you tell me definitively that those two white lines right there are parallel to each other? No, you couldn't. You don't know. They didn't tell you that they're parallel. I mean, that one right there is, let's say that's at 0 degrees. This one could be like 0.0001 degrees, and you'd never be able to just tell by looking at it, would you? All right, so you can't make any assumptions about these lines being parallel. They have to tell you that they're parallel. You hear me? They have to tell you that they're parallel. Here's one way that they could say that they're parallel. So let's call this line L and line N. They could tell you up at the top of the problem, they could say, sometimes they'll use the word given. They don't always do that, but sometimes they'll say it's given that line L is parallel to N. All right? So that's one way they could tell you that those two lines are parallel. Is that all right? It's easy enough, right? They tell you straight up, yeah, they're parallel. So yeah, we know that they're parallel. Here's another way, and you're going to see this quite a bit. They'll put like a little arrow, not at the ends to indicate their lines, but they'll put like a little arrow right here, and they usually put it directly below the other one, or directly across from them. If they put an arrow inside like this, that little symbol right there means that those two lines are parallel. Even if they didn't tell you this, right? Even if they didn't say right here that line L is parallel to N, if they just put a little arrow right there and right there, that automatically means that they're parallel to each other. We good?
Mm-hmm.
All right. So now let's put those numbers in here again. Let's write it just a little bit different, just so we don't get.
I've seen one say it was like no human being could ever make a perfect line.
That's probably true. All right, let's take a look. Now, we have some theorems. I'm not going to write them all down because we wrote all those words. We wrote consecutive interior angles. We wrote corresponding angles. We wrote all that kind of stuff. But I will tell you the first one. The first one is called the corresponding angle postulate. Do you remember talking about that word at the beginning of the year? A postulate means we just accept it as fact, okay? We can't prove it. They just tell us that it's true, so we just believe that it's true, all right? Here's what the corresponding angle postulate says. It says, and every one of these starts off the same way. It starts off saying, if you have two parallel lines, so if there's two parallel lines, parallel lines, if I quit pushing that button, if two parallel lines are cut by a transversal, I'm just gonna leave that are cut by a transversal out, okay? So if you have two parallel lines cut by a transversal, then the corresponding angle postulate says that the corresponding angles, what do you think might be true about them? Which ones are corresponding? 1 and 5. Look at 1 and 5. What do you think might be true about those two angles? Well, they're corresponding. We know that already, but what do you think is the relationship between them? They're equal to each other. Exactly right. They are equal to each other. According to this postulate, the corresponding angles are what? Equal. So that's what the postulate says. That's the name of the postulate. That's what it says. If you have two parallel lines cut by a transversal, then the corresponding angles are equal or congruent. The book says congruent. A lot of times I just say equal. All right? No, just stay here. So if you got two lines and they're parallel, right, and they're cut by a transversal, every one of these corresponding angles are equal. Just for the sake of time, I'm not going to write them all down, but let's say them, all right? So angle 1 must be equal to what? Angle 5. Then 2 is equal to 6, and then angle 3 is equal to angle 7, and angle 4 is equal to angle 8. You can write those down. I'm just not going to for the sake of time, okay? Everybody with me on that? the transversal. So if two parallel lines are cut by a transversal, again, I just didn't feel like writing our cut by transversal. So if you have two parallel lines, then the corresponding angles are equal to each other. The lines have to be parallel. So if I went back up to there, 1 and 3 are corresponding. Are they equal to each other, 1 and 3? No, because I don't know that these are parallel, right? So if these are not parallel to each other, 1 and 3 are not equal to each other. When are they actually equal to each other? When the lines are parallel. That's the only time. So if the two lines are parallel, angle 1 and angle 5 would be equal to each other. 2 and 6, 3 and 7, 4 and 8. They would all be equal to each other. We good with that? What's that? We're going to talk about that in a second. All right. So we have another one. Let's go in order that we showed you all those special angles. What was the second one? Alternate interior. So we have a postulate. Guess what they call it? The alternate interior what? Yeah, I said postulate. I messed up. It's not postulate. They actually call it a theorem. What's the difference between a postulate and a theorem? Well, a theorem you can do what? A postulate you can't do this, but a theorem you can what? You can prove it, okay? So we're not going to take the time because we only have 5 minutes left. So we're not going to take the time to prove any of these, but just know that they can be proven. So we have an alternate interior angle theorem. I'll just shorten all of those, okay? So the alternate interior angle theorem, what do you think it says? If two lines are cut by a transversal, then the what? Then the alternate interior angles are equal to each other. Let's see if they look like they're equal. So which ones are the alternate interior angles? 3 and 6. Do they look equal to each other? Yep. Now, they're not equal just because they look like they are, okay? Don't get me wrong, all right? But the theorem does say that the alternate interior angles are equal to each other. So if you want to write these down, you would say angle 3 equals what? Angle 6. Angle 4 equals angle 5. We good? Okay. Then we also have an alternate what? Exterior angle theorem. Guess what you think? I can't talk. Guess what this one says? We'll say it that way. If you have two lines cut by transversal, or two parallel, not just two lines, but two parallel lines cut by transversal, then what? That's right. Well, not the theorems, but the alternate exterior angles would be equal to each other. Okay, so again, are you keeping a list of these? I'm not writing them down. Hopefully you are. Let's look at the alternate exterior angles. Angle 1 and what? Angle 8. 1 and 8. They are equal to each other. All right, because why? The alternate exterior angle theorem says they are. The alternate exterior angles are equal to each other. What's the other alternate exterior angles? 2 and 7. So angle 2 and angle 7 are also equal to each other. Why? Because alternate exterior angles. Okay? We've got 3 minutes left. Let's do one more. What's the next one? So we've done 3 of the 4. What was the fourth one? Consecutive. Okay? I'll just shorten it. Is that all right? Consecutive interior angle theorem. Now look, 1 and 5, do they look like they're equal to each other? Yeah. Again, don't just go by this, but I'm just showing you that this is true. So all the corresponding angles, yeah, they definitely look. 1 is obtuse, 5 is obtuse, right? 4 is obtuse, 8 is obtuse. It looks like they're equal to each other, right? 2 is acute, 6 is acute. Yeah, they look like they're equal. And then 3 and 7, they're both acute, so they look like they're equal to each other, all right? What about alternate interior? Yeah, 3 and 6, they're both acute, aren't they? So they're equal. What about 4 and 5? They're both obtuse. Yeah, so they're equal. What about the consecutive interior angles, though? So that would be what? 3 and... What's the consecutive interior or the same side interior angle with angle 3?
5.
Angle 5. Now, do they look like they are equal to each other? Definitely not, because 3 is what kind of an angle? It's acute. What kind is 5? It's obtuse. Is there any way an acute angle could be equal to an obtuse angle? No, because by definition, it's impossible for them to be equal to each other. Acute is less than 90. Obtuse is greater than 90. And there's no way the two could be equal to each other. All right? But they do have a relationship. Okay? So if you have two parallel lines cut by transversal, the consecutive interior angles are Supplementary. I'll tell you what that means in a second. Any ideas before I tell you what supplementary means?
The ones across from.
I'll tell you what, let's do this. Let's do this. Let's say angle 1 was, I don't know, what do you think, 150 degrees? Looks pretty close to that, doesn't it? Okay. Let's say that's 150. Logan, are you even watching up here? You even making any attempt to look up here?
Yep.
Now that I say something,
No, I was.
just look up. Don't say anything. Just look up. Look up. Gosh. Let's see all the angles. If I tell you one angle, you should be able to tell me all the rest of the 7, okay? So angle 1 should equal what? Because let's do by corresponding angles. So angle 1 would equal angle 5. So how many degrees is that? 150, okay? What about angle 4? What's angle 4? Why? Because they're vertical angles, right? Vertical angles are equal to each other. So that's 150. What's angle 8? That's 150. Okay? Now, what's angle 2?
30.
Where'd you get 30 from?
The whole line, 180.
Because it adds up to 180. That's right. Okay? Just hang on for a second. They add up to 180. So how many degrees is angle 2? I said hang on for a second. So that would be 30 degrees. What's angle 3? 30 degrees. Angle 6? 30 degrees. Angle 7? 30 degrees. Now, what do you think supplementary? Have a seat. What do you think supplementary means? Consecutive interior angles. So look, this angle and this angle, what do they do? What does the 30 and the 150 do? They add up to be what? 180. So what do you think supplementary means? They add up to be 180. Okay. And let's see. We still got a little bit more to do, but if you want to start on the homework just to get a head start, it's page 111. Well, get them after school. And then 1 to 21. All right, anyway, whatever. Just that's your homework. It's not officially due tomorrow because we didn't quite finish it. So if you have a book and you can get a book, then work on those.